Hi there, in the last video I explained how to work out the angle or the acute angle between a line and a plane, okay? So the formula being sine theta, so theta is the angle between the line and the plane, and that is the absolute of m dot n over the modulus of m times the modulus of n. But I also gave another formula to work out the angle between the normal to the plane and the line. So that formula being cos alpha, that is the absolute of m dot n over the modulus of m times the modulus of n. Okay, so angle between the line and the plane, angle between the normal to the plane and the line. Okay, so I'm going to continue on and try some examples. So example number 1. So let me find my red pen and ruler to underline this. Okay, so the question being, let's find the angle between the line with equation. So the equation of the line is r is equal to I minus j plus 2k plus lambda open a bracket I plus 2j minus 3k, and the plane, and that has equation r dot open a bracket I plus 2j plus 5k, and that is equal to 18. Okay, so let's do the calculation. So remember the formula in the previous video, sine theta, that's the modulus of m dot n over the absolute of m dot n rather over the modulus of m times the modulus of n. Okay, so for me, step number 1, let's calculate m dot n. Okay, so the formula itself depends on the direction vector of the line, so I'll call that m, and the normal vector of the plane, so that is n. Okay, so let me work out firstly m dot n. So m is I plus 2j minus 3k dot with n, which is I plus 2j plus 5k. Okay, so remember the scalar product, multiply the coefficients of I, j and k and then add. So if I multiply the coefficients of I have 1 times 1 plus multiplying the j coefficients 2 times 2 plus multiplying the k coefficients minus 3 times 5. So if I simplify further, 1 times 1 is 1, 2 times 2, 4, minus 3 times 5, minus 15. So that is the solution to m dot n. Okay, so if I simplify further, 1 plus 4 is 5, minus 15, minus 10. So that completes step number 1, m dot n, that is minus 10. Now step number 2. So looking at the formula, we need the modulus of m and the modulus of n. So let's crack on. So modulus of m is going to be the square root of, okay, looking at m, coefficient of I is 1, so 1 squared, plus coefficient of j is 2, so 2 squared, plus coefficient of k minus 3 squared. Okay, so further to that, we're going to have 1 squared, which is 1, 2 squared, 4, minus 3 squared, 9. So if we continue further, I'm going to leave this as root 14. So I'm going to leave it as a root. Okay, that is the modulus of n. Let's work out the modulus of n as well. So it's the square root of. Looking at the normal vector, coefficient of I is 1, so 1 squared, plus coefficient of j is 2, so 2 squared, plus coefficient of k 5, 5 squared. So simplifying further, 1 squared is 1, 2 squared 4, 5 squared 25. So I'm going to leave this as root 30. Okay, so that is the modulus of n. Okay. So now we have all of the data, we have all of the results in order to apply the formula. So remember, to work out the angle between the line and the plane theta, sine theta is the absolute of m dot n over the modulus of m times the modulus of n. Okay, so step number 3, final step, using sine theta, that is equal to the absolute of m dot n over the modulus of m times the modulus of n. So if we substitute what we have in the previous steps, so it's the absolute of m dot n is minus 10 over modulus of m is root 14, modulus of n is root 30. Now remember, before we do an inverse sine, take the absolute first. So the absolute of a negative is a positive. So taking the absolute, it's 10 over root 14 into root 30. Okay, so take the absolute first. And now let's work out the angle. So let me take my calculator here. So I have 10 over, so root 14 multiplied by root 30, and if I do a shift and a sign of the answer, you should end up with 29.2 degrees. Okay, so 29.2 degrees. So there you have it. These are the steps in order to work out the angle, or the acute angle, between a line and a plane. Okay, so that ends this video. I hope you found this video helpful, and do related practice questions, and I hope to see you in the next video. Thank you.